We present an intuitive and straightforward method for synthesizing videos by manipulating objects without 3D models. As shown in the movie, users are able to control the motions of the object directly by clicking and dragging the mouse. By estimating the camera motions, the world coordinates for the video object are retained. The video object and the background video are synthesized into a new video. Firstly, we use a segmentation method for cutting the video objects at each frame, and we define each segmented frame as a video sprite. Then, we constructed a motion graph based on the obtained video sprites, where the nodes represent the video sprites and the edges represent the connection between similar sprites. We compute the corresponding edge weights as the distance and difference in size between the two sprites. New motions are created by making transitions between connected nodes. However, when the current node has multiple edges and edges, we must decide which of the edges is the most suitable for the next transitions. In order to accomplish this, we have employed the tracking of feature points between the connected sprites. As shown in the movie, the green points represent the tracked feature points in each sprite. After this reprocessing step, we can now manipulate the video objects directly. The green points represent the feature points of the current video sprite, as shown in the movie. Whenever we just click the mouse, the closest feature point is selected. When we drag the mouse, a transition to another video sprite occurs, where the chosen sprite is the one whose corresponding feature point is located at a position that closely resembles the dragging displacement. In addition, we implement multiple feature point selection by specifying two types of feature points. The first type, which are denoted by blue points, are to be moved along with the current selected feature point. As a result, we can lift up both hands of the video sprite. The second type, which are denoted by green points, are fixed points that retain the movement as much as possible as shown in the movie. Our method can create new movies by recording the graph transitions, or by setting keynotes and automatically constructing the searching paths between them. Furthermore, our method can connect nodes with relatively different shapes by interpolating between them. As shown in the movie, we acquire feature point-based optical flows between them. We use the feature points as the control points of the deformation technique and their flows as their displacements. By doing so, we can automatically create interpolated frames like this. This is an input video for constructing a motion graph, which has 559 frames. The amount of video sprites was doubled by horizontally mirroring the frames. As you can see, the person executes various 2D motions. The constructed motion graph is then embedded into a background video. This is the resulting synthesized video. The trackbar node represents the frame ID of the original video object, while the trackbar back represents the frame ID of the background video. As you can see from the node trackbar, our system allows random access to the video sprites. This is another original video for creating motion graph, which consists of 630 frames. As you can see, this person walks from back to forth. This is the resulting video after embedding the created motion graph into the background video. As you can see, our method can take the perspective effect into account by scaling the embedded object at each time step, so that we can synthesize motions in the depth directions. This is another video with 885 frames. As you can see, this is a boxing scene in which complex and speedy motions exist. This is the resulting video, and as you can notice, our method can be applied to such motions as well.